Welcome to Mechanics of Materials Part 2. This is a course on thin-walled pressure vessels and torsion. Today's learning outcomes are to again describe the importance of studying mechanics of materials, to outline the general analysis approach, and to list the major topics in the course. First, again, let's look at the engineering mechanics, engineering science, and how they fit into the overall schematic of engineering. So we take math, basic sciences, physics, or how the physical world works, and the engineering mechanics or engineering science courses that you're taking with me are to bridge to the engineering topics such as the one shown here, where we take an application of the science to fulfill a human need. And this again is a schematic you've seen before. It shows where deformable bodies fit into the overall coursework that I've offered in engineering mechanics. So, as I've said in my first course in this series, Mechanics of Materials is a foundation for all structural and machine design. So we start with an engineering structure. In this case, since we're talking about thin-walled pressure vessels and torsion, here's a thin-walled pressure vessel. We're going to apply some external loads to it. Those loads could be a combination of the ones shown here or any individual one shown here. Pressure is the one that we're looking at for a thin-walled pressure vessel. And so once we have those, we're going to model it, look at the internal forces and moments that are generated. They're going to cause some stresses and strains in the structure, and we can analyze those to look at the structural performance to determine whether the structure is going to succeed or fail in what it is supposed to accomplish. So as a review, these were the topics that we studied in the Fundamentals of Stress and Strains, the first course in this series. Now we're looking at thin-walled pressure vessels and torsion, and we'll study each of the topics listed here. The next course will be on beam bending. The last course will be on deflections, buckling, combined loading, and failure theories. And so, as in my previous courses, my emphasis is going to be on the principle of mechanics of materials rather than extensive computation or computer work. Computational computer work is important in these disciplines, but I want you to have a very solid foundation of the basics. And so let's go ahead and get started.